Hey, Mark, would you put the presentation up? Room pres? He's in training. Bottom row, there you go. So I like to kind of, besides calling this NERDfest, it's sort of a list of what's on your workbench. And over the last several years, right about the beginning of the pandemic, they sent us all home and said, you'll come back someday, maybe. And so first thing I did was I bought some test equipment. I filled my workbench up with test equipment, and this is what we're going to talk about. It's called an Analog Discovery, and there's a 2 and a 3. 3 is the current one. This is a 2. We'll talk about what this is. So it starts out as being a USB oscilloscope. If any of you have a small one that plugs into a USB port, it's pretty convenient, but this box is way more than that. And a lot of what it makes it do it is the software, and we're gonna do an overview of what the software brings to that. You get an oscilloscope, a waveform generator, a power supply, a voltmeter, a data logger, a logic analyzer, a spectrum analyzer, the list goes on. So this is a piece of my workbench at home with a service monitor, power supplies, function generator, oscilloscope, voltmeter, frequency counter. And this, that's an Analog Discovery 3, and it's a 2 I have in my hand here, replaces it with some limits, and it's mostly bandwidth limits. Oscilloscope, for example, and we'll look at the specs a little more in a minute, of the Analog Discovery 2 and 3 is 30 megahertz, so it's a 30 megahertz oscilloscope. This happens to be a 500 megahertz oscilloscope, so you're not going to get exactly the same level of performance, but if you're working with microcontrollers and you're working with audio especially, then this is the perfect tool for that. And what makes this work is the software. It's called Waveforms. It's free, runs on a Mac, runs on Linux, and runs on Windows. Notice I said Windows last, because everybody assumes, oh, it runs on Windows, and I'll never be able to use it, but really the Mac and Linux runs on as well. So here's the hardware specs. It's got 2 analog inputs that are used as oscilloscope inputs, but also for the analyzers, the voltmeter. It's 100 megasamples per second, but with the filtering in the oscilloscope, and the averaging going on, you really get about 30 megahertz of bandwidth. And it's good to plus or minus 25 volts. So don't be using this on tube equipment. It would not be happy. The analog outputs are also 14-bit. There's 2 of those, and they're waveform generators. And we'll talk about a little more about that. Again, it's 100 megasamples per second. That's on the analog side. Then on the digital side, there's another 16 channels of digital that can be programmed for input, output, 3.3 volts, but they're 5 volt tolerant. So it's great for Arduinos and Raspberry Pis and whatever you're working with. And there is a programmable power supply in it you can set for, but there's both a plus power supply up to 5 volts and a minus. So if you're doing op amps, you need plus and minus. That's available. And with an external power source, there's a little power jack on the side of this. You can get up to 800 milliamps of power supplied for each one of those rails. One of the things that's really cool about this is there's a double row, so it's 30-pin connector on the end. And if you want to use oscilloscope probes, you plug on the BNC connectors, and now you've got a pair of oscilloscope channels and a pair of waveform generator channels. So you can use it for measuring filters, for example. Happen to have brought some. These are CTCSS high-pass filters. They're kind of cute. but they have a great performance waveform on the network analyzer I'll show you a picture of. And I'll show you how I measure that here in a minute. It also comes with flying leads. So these are, the oscilloscope hooks up to this. And it's a differential input on the analog inputs. So you've got 2 oscilloscope channels as inputs. You've got the 2 waveform generator outputs, and then 16 digital channels and a whole bunch of grounds. So that comes with it. What I did was I ordered a couple extras because that way I can hook it up to my project, and if that project is interrupted, I can go off and do some other project with another one, and I can leave that one all hooked up and not have to mess with it. What else we got? We got the impedance analyzer. So you can look at the impedance of an LC circuit, hook up resistors and inductors and caps. And then they also have a transistor tester adapter for it and an audio adapter for it. The Analog Discovery 2 actually has a headphone jack on it so that you can use the waveform output as a stereo output for whatever kind of testing you're doing. This is here for your reference. I'm not going to read all this. It's got all of the specs for all of the, and it's a sort of a classic oscilloscope. It'll do FFTs and spectrograms. It's got eye diagrams and XY plots. You can do Lissajous plots on it. There's really a lot to it. And the waveform generator, it's not only sine waves, it's sine waves and square waves and triangles and sawtooth and on it, just about all the one. Oh, and it's got one called noise. And literally, it's just randomized noise across whatever bandwidth you specify. It's got cross-channel triggering across things. The analyzers, the spectrum analyzer and network analyzer will also give you distortion. So it's all driven from the waveforms application, and this application opens full screen on whatever computer you're using. You can open one or more tools, and then you can paste them on your screen. It really helps to have a monitor or two if you're doing it, so you can have an oscilloscope over here, and you can put, some digital logic analyzer output that you might be looking at the same time if you're working on some kind of a filter or a decoder, and you want to look at the output of it at the same time. Here's what the oscilloscope looks like. It's sort of your classic oscilloscope where you set a time base and set the amplitude of your 2 channels. This is the waveform generator. Look at the list of signals types of signals you can generate. Sine, square, triangle, ramps, noise, pulses. Power supplies, you can set those between 0.5 volt and 5 volts, one for plus and one for minus. And which one is this? Logic analyzer. So the cool thing about the logic analyzer, and the cool thing about this interface in general is you can open an oscilloscope channel, you can open the logic analyzer channels, and it's got a protocol decoder in it protocol analyzer in it that I'll talk about in a second, where you can look at UARTs, you can look at I2C, SPI, one wire. There's a whole list of things, and you can generate patterns with it. So if you need 8 bits of some kind of varying pattern for a particular kind of a test, you can program it up and it'll play it out at whatever rate you want it to. This is a network analyzer. This waveform I took off my screen, and that's this filter. It's a really nice CTCSS filter made by Masters Communications. That's Kevin Kuster and the Repeater Builder guys. And to test it, what I did was I built a little test board that I'm using to test some other things. And I set it up so I can plug the Analog Discovery 2 onto the end of it, like that. And then I plug this onto this header right here. And now I can, I guess I should be using a close-up camera. You can put the filter on the test board, and you can get that waveform that I show up there. It's really effective, especially for audio. I'm doing a lot of repeater controller and repeater kinds of work, and the equipment is very effective for that. Room presentation. Thanks. Here's the impedance analyzer, looking at the impedance of resistors, capacitors, inductive circuit, or frequency sensitive circuits. Spectrum analyzer. And as I said before, you can put up multiple instruments. So here in this example, you'll see one of these is the oscilloscope, and this is the waveform generator and the power supplies. You put them all on the screen at the same time so that you've got all the various kinds of all your tools available to you. If you're on a smaller screen, if you got lots of screen space, you can spread that out and take advantage of it all. You can also log, and boy, there's been some projects I've worked on where the thing that I'm trying to track down is intermittent, and I need to log over time. Well, this'll log for you. It'll write samples to a log file and be able to play it back for you later so that you can figure out where the glitch is.
Yeah, Dave, we have from Chris Keller it's great to hear a good review of one of these USB oscilloscopes plus tools. I've seen some of them advertised, and they've been generally skeptical. How expensive are the add-on modules?
Great question. So let's start with the base module. The base module itself, of course, with the pandemic screwed up everything, so the price went up like $100. I think it's $379 now, but it's the add-on modules that are really inexpensive. I'm almost surprised that if, so here's the Analog Discovery 2. If you want to, yeah, good. And then the oscilloscope adapter that plugs onto it. And here's the fly-in leads that go with it. The fly-in leads were $15. I think the impedance analyzer's $25 or $30. What was the other? I'll say here in a second that I recommend a bundle that already bundles in the oscilloscope part of that. But it's inexpensive too. I forget exactly, $25, $30. So they're all in that range. And then, making your own is really inexpensive. The connector is just a, double row, right angle, 0.1 spaced, 0.25 square post connector. This is a Samtec. And this is the first board I put it on. I've now put it on a second test board, so I can just move that around and use it where I need it. So, and Chris, if you need a KiCad symbol, I'd be happy to share. It's easy to just pop the symbol up in KiCad and make sure you got it aligned with the edge of the circuit board so that it plugs on right. But other than that, you just look it up. So.
Yeah, Ed, K8 JMW kind of pointed out that there are some of these used on eBay.
Oh, very nice. Oh, it's a great opportunity. And there was an original Analog Discovery and then a 2. This is the 2 that, and I got this in 2020. Analog Discovery 3 came out a year and a half ago or so. And this is the entry level of the family. If you really want benchtop stuff in, heavy cabinets, there's actually a 2-channel and a 4-channel USB oscilloscope in a box that you put up on the shelf. You still use a computer and the waveform software, but it's all compatible all up and down. Now, the other thing this is really good for is scripting. And if you're doing a onesie, if you're just using it on your bench and scripting may not be as attractive, but if you're doing production of, let's say I was testing these filters and I was going to build 50, I might drop them on the board, run the script, which will automatically program the frequency spread that I want and run the network analyzer and compare the results and complain if it's wrong. I actually built one that didn't work and I forgot to solder a pin, so it caught it for me. It was really, really quite productive. So I recommend the bundles. There's this bundle shown here on the right side of the screen is the Analog Discovery 2. It already comes with the flying leads, and I think it comes with a USB cable as well. Analog Discovery 3, I'm pretty sure, is a USB-C connector. This older one is a USB micro B. You get a couple of oscilloscope probes and the oscilloscope adapter and some clips. It's wonderfully lightweight, and Willem, you probably remember the nice walk on a sunny day we had up the top of Squaw Mountain, and we got Dave to backpack up a power amplifier. And as we were doing that, I was dreading the day I'd have to carry a service monitor up. Well, all I really need is a laptop in this box at the top of a mountain, let's say, to change a repeater controller in order to set audio levels, because it's light. You just drop it in your backpack and forget about it.
Come with an oxygen supply for the altitude?
That option wasn't offered in this bundle, but we could have used it that day. You can also add the connector to your own projects. There's the Samtec connector number. If you're going to build one, and if you need scope probes, order the bundle. Otherwise, just get the adapter. And here's a list of references. This will take you right to the web pages. The third one down there, the waveforms reference manual. It's full of examples of how to set up the tools and use them to test various kinds of circuits. The impedance analyzer, the network analyzer, the waveform generator. And did I make somewhere in here? There's the protocol analyzer in the middle. SPI, I2C, CAN, AVR, UART, and one. That list originally didn't have one wire on it. I went and looked. It actually has one wire decoding. You can get temperature sensor cables that are one wire. One wire is a single wire protocol for powering a device and reading the data back. So really, really useful. Stereo amplifier built in. And I didn't point out that there is a software development kit that goes with it. So if you want to write custom Python scripts or programs to do special testing with this, you can actually use it to drive a test environment. The SDK is free. The waveform software is free. And there is a toolkit that makes it work with LabVIEW. I think Digilent got bought by National Instruments, if I remember. Anyway, they have LabVIEW. So you can kind of integrate the whole thing into a programmable test environment for manufacturing or a reproducible engineering level test that you need to do kind of over time. Any other specific questions?
Protocol analyzer, is it parasitic, so you can view the protocol that's being generated by another device, or will it actually be the source for generating those signals?
Yes. It'll actually do both. You can spy on a protocol that's flying by, or you can be the master. And you could drive the transaction. So I_C, you can go out and exercise a particular device that let's say you bought an Adafruit plug-in board and you wanted to be able to read, get it to do whatever, like maybe it's a double EEPROM or maybe it's an A to D converter, and you want to exercise it before you write a bunch of code to talk to it, you could use this to do that. We've got a project going on now where we're looking at the SPI bus that's being mastered in a radio coming out to an option board, and we're looking at the protocol as it flies by to make sure we understand that we're interfacing it properly. So really useful. Dean?
Does a logic analyzer do state analysis
I believe it does.
if I provide my own clock? A lot of these are timing only, but I've never looked at this one.
It's pretty flexible. I would look in the waveforms manual at the protocol, at the logic analyzer.
And do you know if the timing analyzer will do transitional timing? So if I'm looking for a 1 microsecond pulse that only happens every hour or two, can I
know
just
it has
turn it on?
I know it has triggering, so there's ways to use the triggers where you can trigger in one channel and have it start one of the other tools. There's a couple of cross triggers available.
And have you seen any like user contributed decoders for digital protocols?
I have not seen that.
Okay, I just wonder if
Yeah,
there's a group that does that kind of thing, or if there's a repository somewhere.
There is a whole community that's kind of rolled up around this. Digilent has sponsors a forums area. It has a lot of conversation about different uses for the tools.
Have you played with the software development kit at all, or?
I have not yet. I haven't gotten to the manufacturing step yet. That's coming. But that's going to be one use for it, is to do testing and manufacturing and plug that onto the end for that purpose. Woohoo! That's a good deal. That'll be the third one that I've encouraged somebody to buy. Well, you're retired now. You got to be a little more thrifty. And that's what I got. Don't forget all the references on the last slide here. And there's a hardware design guide too, so you can, if you're going to design your own board, when you plug it in, what to expect on the pins and the signal levels on the pins. Okay.
Magic smoke out of one of the add-on boards yet? To what extent are the add-on boards protective of the main system?
I would say the add-on boards like this one is circuitry and 6 connectors. And that's about it. There's no additional protection besides what's in the module itself. The module, the core of the module is an FPGA. So let's take, for example, if the logical I/O, the digital inputs and outputs are wired directly to it, you don't want to go over 5 volts. And you need to be ESD protected if you're going to play with it, right? So I've heard of the guy who had one in his backpack while he was on an airplane, and he was writing software, and he had it plugged into his unit under test, and he was running tests on it. So, I mean, they are pretty forgiving, it seems like. Yeah, they're amazingly versatile and useful. So definitely worth. If you don't have a workbench that big to put all the rest of that stuff on, then this is a really good way to get started with, like HF and down with an oscilloscope and spectrum analyzer and things like that. Okay. Do we take a 10-minute break?